Hello, hi everyone, good afternoon, welcome all. So we are going to learn the next topic for this pioneer batch. It is magnification due to spherical mirrors. So हमने spherical mirror देखा, mirror की properties देखी, दो type के mirrors है, there is a concave mirror and a convex mirror. तो हमने last class में mirror equation भी देख लिया, image formation भी देख लिया. अब last topic बचा है, there is a magnification. So let's begin. So just say hi, hello if you are watching this video. Hello Sonu, Kushwaha, good afternoon. So this is about me. If anyone is seeing me for the first time, I have a PhD in physics from Singapore, BSMS dual degree from IISER Pune as ranker in JEE Advanced and KPY. Alright, hi Shantanu, hello. So let's begin. So this I'll quickly revise. Do I have space here? No space. Alright. Quickly revise what is the sign convention. We have done a like last lecture I have taught this in much detail. What is the sign convention? If you still don't know, go back to the earlier video and do watch what is the sign convention for the spherical mirrors. Hi Mrinmay, okay. मृण्मय देवनाथ लैग कर रहा है, there is lag. Okay, let me check. यहाँ पे लैग हो रहा है क्या? No lag, right? Okay. All right. Maybe check your internet, Mrinmay. There could be some internet issues from your side, just check that. Alright, so now the sign convention, it is very simple, very easy. So I'll tell you the basic rules of the sign convention. First rule, the object should always be on the left. So the object should be here, this would be the object. Object should always be on the left of the mirror. This is a reflecting surface of the mirror. It can be concave or convex. This point, which is the center of the mirror, it is our pole, and this pole will act like a origin, correct? So this x-axis, this x-axis will act like our principal axis, and then draw a imaginary line perpendicular to the principal axis passing through the pole. So that would be our y-axis. So now this will look like a Cartesian system. Yes. So in the Cartesian system, if you go to the right side, there is a positive direction of the x. So it would be positive. So all the distances which are measured along the x-axis on the right side are positive. Distances measured along the x-axis on the left side are going to be negative. These are the negative distances on the left side. If you go upwards, there is positive y-axis, so upward would be positive, downward is negative. So this is the sign convention for the spherical mirrors, for both of them, concave or convex. Clear? It's okay now? Alright, great. Now after sign convention, we have learned mirror formula. So this formula is called as mirror formula. It is very important, and you can use the mirror formula correctly only when you take care of the sign convention. Mirror formula is very simple, very easy to use, but you guys make a mistake. आपकी गलती कहाँ पे होती है? Sign convention में. अगर sign आपने गलत डाल दिया, then your total question is going to be wrong. So you can use the mirror formula only when the sign convention is correct. Okay? So now what are these? V is the image distance. All the distances you measure from the pole. There is a pole, right? So all the distances which are on the x-axis, you measure it from the pole. Then the U is the object distance, F is the focal length. Now we have two mirrors, concave and convex. There is a concave mirror and there is a convex mirror, right? So for the concave mirror, there is a principal axis and there is our focus. There is a pole. For the convex mirror, there is a principal axis, there is a pole and focus. So for concave mirror, this is the focal length and we go towards left. From the pole we go towards left. Here from the pole we go towards right. There is a focal length. So focal length for the concave mirror is negative and for the convex mirror it is positive. This is also part of the sign convention rules. Okay, I hope this is clear until now. And there is another formula which is called as magnification. So what is magnification? It is simply this ratio. So what is magnification? It is height of the image divided by height of the object. Simply this ratio is called as magnification. Also for the magnification you need to consider proper sign convention. So usually what we do is we keep the object above principal axis. Why we do that? If you place the object above principal axis, height of the object would be positive, right? So let's suppose if I have concave mirror, if I place the object here, there is an object. So height of the object would be positive, and with respect to object, the image, let's suppose if it is a virtual image, it will be something like this. There is an image. So now this image is a virtual image. So when you get a virtual image, this height of the image will also be positive. How about a real image? Let's suppose you have a concave mirror. You place an object. Let's suppose there is a focus, center of curvature, there is an object. And you get the image somewhere here. There is an image. So now in this case, object is above principal axis. Object above principal axis, but image is below. So height of the object is positive, height of the image would be negative, right? थोड़ा सा हिंदी, all right, I'll speak in Hindi little bit, थोड़ा हिंदी में बोलता हूँ. तो magnification क्या है? M, हम लेटर M यूज करते हैं for the magnification. ये simply a ratio है. Height HI is the height of the image. Image का जो height है उसको बोलते हैं हम HI and HO is the height of object. Object का जो भी length है या height है उसको बोलते हैं height of the object. So now अगर object principal axis के ऊपर है, अगर object principal axis के ऊपर है, then the height of the object या object की height क्या होगी? ये हमारी positive बन जाएगी. This would be positive. और image अगर प्रिंसिपल एक्सिस के नीचे है तो इसका हाइट क्या होगा? सो इन दिस केस हाइट ऑफ द इमेज क्या होगा? नेगेटिव, है ना? क्यों? क्योंकि इमेज कहां है? नीचे फॉर्म हो रही है. क्लियर? सो दैट इज द मैग्निफिकेशन. सो लेट्स सॉल्व फ्यू क्वेश्चंस, फ्यू डायरेक्ट क्वेश्चंस लाइक अ सिंपल इजी न्यूमेरिकल क्वेश्चंस. So what is the question? In case of virtual and erect image, अगर हमारी इमेज जो फॉर्म हो रही है, इट इज वर्चुअल एंड इरेक्ट इमेज, मैग्निफिकेशन ऑफ अ स्फेरिकल मिरर इज, क्या होगा मैग्निफिकेशन? बताओ फटाफट. सो हमें दो चीजें यहां पे यूज करनी होगी, दो चीजें यूज करनी है. एक तो साइन कन्वेंशन प्रॉपर होना चाहिए आपका, एंड देन जो रे डायग्राम्स है वो थोड़ी सी आपको आनी चाहिए. देन यू कैन सॉल्व दीज काइंड ऑफ क्वेश्चंस. आई वांट दिस, ओके, ऑलराइट. सो अभी क्या करेंगे हम? यहां पे दे हैव सेट स्फेरिकल मिरर, बट दे हैव नॉट मेंशन्ड कि कौन सा स्फेरिकल मिरर, इफ इट इज कॉनकेव और कॉन्वेक्स. तो चलो दोनों के बारे में देखते हैं हम. इफ इट इज कॉनकेव मिरर, ये हमारा कॉनकेव मिरर है, एंड लेट्स सपोज दिस इज हमारा कॉन्वेक्स मिरर. नाउ द इमेज इज virtual and erect image. So when will you get a virtual and erect image for the concave mirror? अगर यहां पे फोकस है हमारा ऑब्जेक्ट, there is an object, so in this case this would be the image, है ना? Then there is a virtual and erect image. बट इफ इट इज अ कॉन्वेक्स मिरर, अगर कॉन्वेक्स मिरर है, आप कहीं पे भी ऑब्जेक्ट रख सकते हो, ऑब्जेक्ट कैन बी वेरी क्लोज, और बहुत दूर भी रख सकते हो मिरर से। अगर ये हमारा ऑब्जेक्ट है, इफ देयर इज अ ऑब्जेक्ट, देन व्हाट विल हैपन, देयर इज अ पोल और यहां पे फोकस है, तो इमेज कहां पे फॉर्म होगी, इमेज यहां पे फॉर्म होगी पोल और फोकस के बीच में, ये हमारी इमेज है ना। नाउ इन बोथ केसेस इमेज कैसी है, वर्चुअल, वर्चुअल मतलब बिहाइंड द मिरर, एंड इरेक्ट, इरेक्ट मतलब इमेज इज अपराइट विथ रिस्पेक्ट टू द ऑब्जेक्ट, ये मीनिंग है उसका। तो इन दिस केस मैग्निफिकेशन क्या होगा, व्हाट इज द मैग्निफिकेशन, मैग्निफिकेशन क्या होगा, आंसर इज पॉजिटिव, नेगेटिव, इंफिनिटी एंड जीरो। सो इन बोथ केसेस यहां पे हम लिख सकते हैं हाइट ऑफ द ऑब्जेक्ट एंड हाइट ऑफ द इमेज, ये दोनों पॉजिटिव है ना, दोनों पॉजिटिव है। इन दिस केस ऑल्सो हाइट ऑफ द इमेज इज पॉजिटिव, हाइट ऑफ द ऑब्जेक्ट पॉजिटिव, दोनों केस में सारी जो हाइट्स है, हाइट ऑफ द इमेज एंड हाइट ऑफ द ऑब्जेक्ट सब पॉजिटिव है। तो उनका रेशियो क्या होगा, इट इज सिंपली द रेशियो ऑफ टू पॉजिटिव नंबर्स, दो पॉजिटिव नंबर ले लो आप कोई भी, उनका रेशियो क्या होगा, हमेशा वो पॉजिटिव होगा, राइट। अगर मान लो हाइट ऑफ द इमेज है 2 मीटर्स, हाइट ऑफ द ऑब्जेक्ट है लेट्स सपोज सम 1 मीटर, दोनों पॉजिटिव नंबर्स है ना, तो दोनों पॉजिटिव नंबर होंगे तो उसका जो रेशियो होगा दैट विल बी पॉजिटिव। तो यहां पे मैग्निफिकेशन क्या होगा, इट इज अ पॉजिटिव नंबर। मैग्निफिकेशन क्या है हमारा, मैग्निफिकेशन इज हाइट ऑफ द इमेज डिवाइडेड बाय हाइट ऑफ द ऑब्जेक्ट, and this ratio is positive number for virtual and erect image. Clear है सबको, आशु, मृन्मय, शंतनु, इजी, बहुत सिंपल कंसेप्ट है। चलो और क्वेश्चन सॉल्व करते हैं, सम मोर एमसीक्यूज, लेट्स सॉल्व। बहुत ही इजी क्वेश्चन है, एंड दीज आर लाइक सम ऑफ दीज क्वेश्चंस आर फ्रॉम योर NTSE, very straightforward questions, but a lot of you get confused. So what is the question, what type of mirror can have magnification is equal to 1? So option is concave, convex, plane mirror, cylindrical mirror. So कौन से मिरर में मैग्निफिकेशन इज इक्वल टू 1? concave and plane, okay, concave is not correct, plane mirror yes that is correct. So what is magnification, again I am writing magnification क्या होता है, height of the image divided by height of the object, it is given as +1, magnification is given as +1। तो यहां पे हम अगर क्रॉस मल्टीप्लाई करोगे तो क्या मिलेगा, हाइट ऑफ द इमेज इज इक्वल टू हाइट ऑफ द ऑब्जेक्ट, ये मिल गया। तो व्हाट इज द मीनिंग ऑफ दिस, इसका मतलब क्या है, इसका मतलब ये है अगर जो भी ऑब्जेक्ट का हाइट है दैट वुड बी द हाइट ऑफ द ऑब्जेक्ट, दोनों का जो लेंथ है, दोनों का लेंथ हमेशा सेम होगा, एंड नॉट ओनली दैट देयर साइन इज सेम, अगर दोनों का साइन अगर सेम होगा दैट मीन्स इमेज इज वर्चुअल। सो इसका मीनिंग ये है इमेज has same size and it is a virtual image. So when do you get same size and a virtual image? Only possible जब आपके पास प्लेन मिरर होगा, है ना, तभी आपको वर्चुअल इमेज मिलेगी जो कि सेम साइज में है। अगर मान लो कॉन्वेक्स मिरर ले लिया तो वर्चुअल तो मिल जाएगी बट सेम साइज नहीं होगी, कॉन्वेक्स में डिमिनिश्ड होगी, राइट, डिमिनिश्ड एंड वर्चुअल। एंड अगर कॉन्केव ले लिया और अगर आपको वर्चुअल इमेज चाहिए तो इसमें इनलार्ज्ड एंड वर्चुअल मिलेगा, है ना। तो दैट इज द रीजन कॉन्केव एंड कॉन्वेक्स आएगा नहीं। एंड सिलेंड्रिकल, the magnification is very complicated in cylindrical mirrors, so we are not going to consider them right now, okay. So only correct option is your plane mirror. Easy, nice, Kalpana, great. Ashu, awesome. So let's solve the next question. The magnification due to concave mirror is 0. Magnification is 0. So what is the position of the object? Hello Shweta, good afternoon. So कैसे सॉल्व करोगे ये? क्या दिया यहाँ पे? Magnification due to concave mirror is 0. So what is magnification? It is height of the image divided by height of the object. It is given as 0. So what is the position of the object? ये पूछा है, बताओ जल्दी से क्या होगा? At pole, at focus, at the center of curvature, at infinity. Hello Santosh, good afternoon. So again you can use a simple trick here. तो यहां से क्या मिलेगा आपको? There can be two situations. The first situation is you do the cross multiplication. यहां पे अगर cross multiplication कर लिया तो what you will get? Height of the image is 0. If the height of the image is 0, what is the meaning of this? इसका मतलब क्या है बताओ जल्दी से, कौन बता सकता है? इमेज का हाइट 0 होगा, कब होता है? दैट मीन्स ये कौन सी इमेज है? पॉइंट साइज इमेज. पॉइंट साइज इमेज आपको कब मिलती है? कब मिलती है बताओ आपको? वेयर डू यू गेट अ पॉइंट साइज इमेज? इन अ कॉनकेव मिरर. नाइस कल्पना, ग्रेट. यस, तो अगर अपने पास कॉनकेव मिरर है, देयर इज अ कॉनकेव मिरर, प्रिंसिपल एक्सिस, तो यहां पे इफ यू प्लेस द ऑब्जेक्ट एट इंफिनिटी, देयर इज अ ऑब्जेक्ट एट इंफिनिटी, व्हेन यू प्लेस द ऑब्जेक्ट एट इंफिनिटी, it will form the image at the focus. Image will be at focus and it is a point size. That is the meaning of height of image is equal to 0. So where will you keep the, what is the position of the object? Object will be at infinity. That is the right answer. Clear? Easy hai? Nice. Santosh, Kalpana, Krishna, Ashu, Shweta, awesome. Let's solve few more questions. Yes, correct. If the object is placed at center of curvature in front of a concave mirror, what is the magnification? Very straightforward question. Tell me, answer. We have a concave mirror, object is placed at center of curvature. So let's suppose we have a concave mirror here, there is a concave mirror, there is a focus, pole and center of curvature. So there is an object. When you place the object at center of curvature, where will you get the image? So this will be the image. Plus 1 is not correct. Plus 1 is not correct. Tell me why it is not correct. You forgot the sign convention. What is the sign convention? There is an object. Object is above principal axis. So height of the object is the height of the image. So height of the object is positive. Height of the image is negative. Height of the object is negative. Object is, image is below the principal axis. Object is above the principal axis. So what is magnification? And these two are equal. So when you place the object at center of curvature, height of the object, the magnitude wise, they are equal. Magnitude wise they are equal. Their size is same. So the magnitude is same. But you need to consider the sign convention. So what should be the magnitude of magnification? So magnitude of magnification is magnitude of this, height of the image divided by height of the object, which will come out to be 1. सो दिस इज अ मैग्नीट्यूड. मैग्निफिकेशन का जो वैल्यू है, मैग्नीट्यूड मीनिंग जो वैल्यू है मैग्निफिकेशन का वो 1 होगा. बट अभी साइन कन्वेंशन हमें यूज करना है. और साइन कन्वेंशन क्या बोलता है? एक चीज पॉजिटिव है, दूसरा चीज नेगेटिव है. सो व्हाट इज द रेशियो ऑफ वन पॉजिटिव नंबर, वन नेगेटिव नंबर? सो इट कुड बी लाइक समथिंग लाइक इमेज इज -3 डिवाइडेड बाय 3. सो ये क्या आएगा? -1. सो मैग्निफिकेशन क्या आएगा इस केस में? इट इज -1. राइट? सो दैट इज द करेक्ट ऑप्शन. +1 हमने देखा ना, इट इज इन द केस ऑफ प्लेन मिरर. यू रिमेंबर वी सॉल्व वन क्वेश्चन, मैग्निफिकेशन वाज +1 फॉर द केस ऑफ प्लेन मिरर, है ना. अगर कॉन्केव मिरर है तो इट वुड बी -1. क्लियर? आशु, कल्पना, कृष्णा, संतोष, नाइस. नाउ सॉल्व दिस. Sorry. Magnification produced by a rear view mirror fitted in the vehicles is. So rear view mirror कहाँ पे होता है? Where do you use? I mean, what type of mirror it is? कौन सा वाला मिरर होता है ये? These are concave और convex. क्या होता है? These are convex mirrors. These are convex mirrors which are fitted in the vehicles. Yes, nice. Less than 1. All right. Yes, correct. So what is a magnification? So when you use a convex mirror, हमेशा क्या होगा? If there is a convex mirror, if you place the object here, this would be the image. Image is always going to be diminished and both are positive. You see, the image is virtual and erect. Always it will form between focus and there is a pole in these 2 points. Image is always virtual and erect. So both of them, height of the object and height of the image is positive, but image is diminished, and that is the reason magnification is less than 1. It is not more than 1, not equal to 1. When it will be equal to 1? If it is a plane mirror. If it is a plane mirror, then only it is equal to 1. Then can be more or less? No, that is not correct. Clear? Yes, Vivi Chams, correct. Krishna, correct, nice. Now, let's do some special cases. Understand some few like special cases. This is helpful. So when you get a question, sometimes it is very difficult to understand what exactly is happening. So I want to show you few special cases. Okay. The first one, the magnification of a convex mirror. There is an image. These are the ray diagrams. So there is our object. You can place the object at any location in front of a convex mirror. So in that case क्या होगा? These are the incident rays. First incident ray parallel to the principal axis. There is a reflected ray, right, which is reflecting from the focus. The second incident ray, which is towards the center of curvature, it will get reflected in this direction. So these two reflected rays, they are not going to meet each other. They are diverging. So this is our image. Now what are the properties of this image? So if, let's suppose we assume that object is above the principal axis. So if height of the object is positive, that means object is above principal axis. In that case, what will happen? Height of the image is positive. So image is virtual and erect. Correct? Image क्या होगी? It is virtual and erect. So I'll write down the properties of the image. Image is virtual and erect and also and diminished. Virtual, erect and diminished. So in that case, image is diminished. So that means height of the image is lesser than height of the object. Clear? So from this what we can say, if you divide both sides by height of the object, so you will get height of the object divided by height of the object, which is greater than height of the image divided by height of the object. Dividing this equation by height of the object. So now this height of the object divided by height of the object, it is 1. So you can write this as 1, which is greater than, what is this ratio? This ratio is nothing but our magnification. So the magnification is less than 1. It is not equal. It is always going to be less than 1. And there is one more thing, that both of them are virtual and erect. In that, I mean, the image is virtual and erect. So both of them, that is height of the image and height of the object, both are positive. So this magnification is positive. So it should be greater than 0. So that would be our magnification. So whenever you have a convex mirror, magnification will always be between 1 and 0, and it is a positive number. Clear? So this is for the convex mirror. Let's understand for the concave mirror. In the concave mirror, we have two different cases. The first case is when image is virtual. You see here, there is our object and there is an image. So when you get a virtual image, what are the properties of this image? So this image is virtual and erect and enlarged. Right? So let's write down some properties. So if the object is above principal axis, so whenever you keep an object above principal axis, so now I am like in the earlier case also I told if the object is above principal axis, but you can do the exact same thing when the object is below principal axis. So you can draw the ray diagrams. For example, in the convex mirror, if this is your object, then this will be your image, right? This is the pole and focus. So in this case, both of them are negative. The object height is negative, image height is negative. So ratio of two negative numbers. So it would be something like height of the image, let's suppose hi is in this case negative number, let's call it as -1 centimeter, and height of the object, again there is a negative number but is larger, let's say it is, let's suppose -2 centimeter. So height of the image divided by height of the object, which is our magnification, this will be how much? -1 divided by -2, this will be 1/2, again a positive number. So even if you place the object below principal axis, still you will get the same equation. Okay, so this I have taken just to simplify your understanding. Now again we are repeating the similar thing. If the object is above principal axis, what will happen? Then image, height of the image, it is for the virtual image, then height of the image will also be positive. So in that case, both of them are positive, so magnification will be positive. You got this? Both are above principal axis, so magnification, which is height of the image divided by height of the object, should be a positive number. Okay, there is a positive number, but there is one more thing, that is image is enlarged. That means height of the image is greater than height of the object. So again you can divide this by height of the object. So height of the image divided by height of the object to both sides. So what is this number? This ratio is our magnification. There is a magnification which is, what is this number? It is simply 1. So magnification for the concave mirror when the image is a virtual image is always greater than 1. Always greater than 1. And there is another case. Let's suppose we take the concave mirror, but it is a real image. Concave mirror and the real image. So there are different cases now. Let's suppose object is at infinity. What will happen? Image would be at focus. You bring the object closer. So there is your object. Object is beyond C. So there is your image. Right? So in this case, object is larger, image is shorter. So it is a diminished image. Real and inverted. In this case, it is diminished. Now, when you bring the object at the center of curvature, if there is one more case here, at center of curvature. So in this case, the image properties would be, these are image properties, image would be same size. And now, if you bring the object even closer, so you see this object is between center of curvature and the focus. So in that case, you will get the image. So there is an image, there is an enlarged image, there is a enlarged image. So there are three types of image you get. You can get a diminished image, you can get an image which is same size, you can get an image which is enlarged. So now understand some more properties. Again, in all the cases, I have assumed the object to be above principal axis. So if the object is above principal axis, for all of these cases, image is going to be negative. Image is below the principal axis. So that means height of the image is negative. Height of the object is positive, all the cases, and height of the image is always negative. In that case, what will happen to the magnification? Magnification is negative. So whenever you have a concave mirror and you get a real image, magnification is always going to be negative number. Okay? Alright. So that's it. These are, okay, we have the match the following. So these are the different cases, the special cases I would say for the magnification. So when the magnification is less than 0, what type of mirror it is? It is going to be our concave mirror. Magnification which is negative. Now the magnification is positive but less than 1. Magnification is positive but less than 1. It is our convex mirror. Then magnification is equal to plus 1. When do you get magnification is equal to plus 1? If it is a plane mirror, and magnification greater than 1. It is possible if it is a, again, concave mirror, right? So this is for the virtual image, and this is for the real image. So now again one more thing I want to tell you, whenever it is a real image, magnification is always less than 0. For the real image, magnification is always going to be negative, less than or equal to 0. If it is a virtual image, then magnification is always going to be positive number. It can be any mirror. You can use plane mirror, concave mirror, convex mirror. Whenever it is a virtual image, magnification will always be a positive number. But if it is a real image, magnification will always be a negative number. Alright. Video of ray diagrams. So I have done this, Ashu. You can go back. There is a video on all the ray diagrams for the mirrors. You can go back. I think couple of videos back we have done all the different cases, and with the animation you can check that. For the lens, I'll do it after couple of lectures. So come back again, we'll do the ray diagrams for the lens. Alright. Okay, let's solve last question. This, you have to use everything, whatever we have learned till now. The mirror equation, sign convention and magnification. Use everything to solve this question. These type of questions typically come in your CBSE board exams, and that would be like a 4-mark question. 4-mark question. Standard numerical from physics. Let's understand what are the different things given here. An object 4 centimeter in size. Object 4 centimeter in size, that means this is given as height of the object, given as 4 centimeters. Placed at a 25 centimeter in front of a concave mirror. So let's draw. So whenever you get such numerical question, you should draw a rough ray diagram. Rough ray diagram. You don't need proper ray diagram. So there is a concave mirror. You don't have to draw this here all the time, but up to you. So okay, this is a object distance. So you'll keep the object here. There is an object. So this object distance u is going to be negative, which is minus 25 centimeters. So this is our object distance u. There is a pole. Okay. The focal length is 15 centimeter. If the focal length is 15 centimeter, there is a concave mirror. So focal length is going to be a negative number. Focal length क्या होगी इसकी? Negative number होगा, है ना? तो focal length is minus 15 centimeter. तो यहाँ पे अपना focus है. There is a center of curvature. Object is between center of curvature and focal length. इन दोनों के बीच में हम अपना object है ना? Clear? What else is given? At what distance from the mirror should a screen be placed? Now they have asked screen. So when can you use a screen? If it is a real image. So there is a real image. So यहाँ पे हमें बोला गया है the image is a real image. So where will you place a screen so that you will get a sharp image? That means हमें यहाँ पे calculate करना है what is the image distance. So what is this V? You need to calculate the value of V, right? And then the size and the nature of the image. So this is what you need to calculate. So how will you find this? We have the mirror equation 1 by V plus 1 by U is equal to 1 by F. Correct? So from here 1 by V is equal to 1 by F minus 1 by U. Substitute the values. What is F? Minus 15, U is minus 25. F is minus 15 minus minus 25. So this minus minus it would be plus. What is the LCM of 25 and 15? It is 75. So LCM is 75. 15 into 5 will give you 75, so which is minus 5, and 25 into 3. So that would be plus 3. So this you will get as, so 1 by V is equal to minus 2 by 75. So from here what is value of V? V is equal to minus 75 by 2, which is minus 37.5 centimeter. So there is a, from pole to the center of curvature, this is 30. So you will get the image somewhere here. There is the image and this is the value of V. Again there is a minus sign, minus 37, that means there is a real image. Real and inverted image. So what is the nature? Nature is real and inverted image. Real and inverted image. So now we want to find out size of the image. So how will you calculate the size of the image? So there is a formula for magnification. Do you remember magnification formula? So we know that, do I have more space? No. So magnification is height of the image divided by height of the object. And there is one more formula for it. So this, you can draw the similar triangles and you can prove that this is equal to minus V by U. Okay. So this magnification is equal to minus V by U. There is another formula for magnification. So from here, I'll use a space somewhere here. I'll write here. So height of the image will be minus V by U multiplied by height of the object. Okay. So this is the height of the image. So let's just substitute all the values. What is V? V is minus 72 by 2, 75 by 2. So minus of minus 75 by 2. What is U value? U is minus 25, minus 25. And what is height of the object? Height of the object is 4 centimeter. So this is multiplied by 4 centimeter. Now you can cancel this minus minus sign. So what you will get is this 2, you can cancel it out. So 2 into 1, 2 into 2, and this 25 into 1, 25 into 3. So what you will get is this 3 multiplied by 2, which is, and there is a minus sign here, so minus 6 centimeter. So this is the height of the image. What is the height of the image? Minus 6 centimeter. So what does that tell you? It tells you that the image is enlarged. So I'll write down here, height of the image is minus 6 centimeter. That means the image is enlarged. It is real and inverted. So again, there is a minus sign here. That means the image is inverted. There is downwards. You measure the height below the principal axis. Okay. So that's it for today. Thank you so much everyone. If you have any questions regarding the ray diagrams, do watch the earlier videos. Even for the sign convention, there was one more video just before this. Do watch all these videos. Okay. Alright everyone, bye bye. From the next class, we'll start with the laws of refraction. How the refraction happens. Okay. We'll start with those. Alright. So that's it for today. Bye bye.